Okay. Let's get started. Hi, everyone. My name's Lars, and I'm going to tell you about Locust. Just to start off, how many of you have done load testing yourselves? Awesome. That's a lot of people. Good, good. I think we can get some more after this, maybe. So Locust is a performance testing tool, and it's written in pure Python, and it has a lot of nice features. And I can't go to the next slide. There we go. There we go. So it's on GitHub. It was originally written by a guy called Jonathan Heyman. It was publicly released in 2011, and I am its primary maintainer since about 2019. It's open source, MIT license. There's no paid version or anything. There's no corporate sponsorship or anything. It's just community maintained. And it is quite of a nice, big community. We have a Slack, and we have people answering questions on GitHub and Stack Overflow and everything. According to PyPy, we have about 1.3 million downloads every month. So I don't think those are all people, but that's a lot, right? But a little bit about me. I've worked with performance testing for about 15 years, and a lot with Python and, of course, with Locust. But I thought it was kind of interesting what Carol said this morning, and I am a beginner. So, and I'm a beginner speaking at a conference. So any mistakes I make is because she told me so. I work as an independent contractor. My company's name is Red Shirt Consulting, which you can't really see, the red, and it's better on white, my logo. Anyways, so I always wear a red shirt. No, not always, but sometimes. And today I took the one that was most closely matching our beautiful organizers. So I've used Locust at Svenska Spel, the state-owned gambling operator, and also Klarna before that. The name Red Shirt is not in reference to anything in particular. It's just a nice color of a shirt. Although, if you're a fan of Star Trek, I can recommend this book. It's about, let's call it the dangers of going on a mission if you're not a main character. All right, so let's get into it. Why should you use Locust? The main reason you should use Locust is because you can define your tests in real Python. That makes it super easy to do complex behavior, loops, conditional behavior, or generate test data on the fly, do any kind of processing that would normally happen on your client. And because it's source code and not some XML file or whatever that your tests get saved in, you can diff it, you can commit it to Git, you can collaborate much more easy. And also because it's Python, code reuse is as simple as importing a module, really. Another reason you should use Locust is because it has a nice master worker architecture where you launch a bunch of processes on some load generator, and then you run a master process either on your local machine or on a different server, and workers will send aggregated data to the master. And it's easy to use in CI scenarios because you can configure it using just plain command line parameters or environment variables or configuration files. So that's nice. And you can test almost any protocol. It's built with HTTP in mind, but there are extra add-ons you can use, and you can write your own code to test any protocol, really, as long as it's G-event friendly. So if it's pure Python, then it's fine. If it's C code, then it should work in most cases, but depends on the library. So yeah, I'm going to do a quick demo, and we're going to have a look at a simple test script, and then I'm going to run it in the debugger, of course, because we like debugging, and then a real test where I just briefly look at some results, like how to analyze results, because that's really the hard part of performance testing. And then I'm going to show you just how to run it without the GUI. Let's see if I can find my screen. All right. So this is basically the, oh no, the screen is not working. Okay. This is basically the most simple Locust script that you can write. We define a user class, which is basically a type of user. It could be a slow user, it could be a retail user, it could be a mobile user, whatever you want. That's the concept anyway. And it subclasses some base user class based on like what protocol it's using. You can inherit classes, you can build your whole class hierarchy if you want. So you can do subtypes of your users and whatnot. But anyways, the important thing about the user is that it defines tasks. Tasks will be called by Locust. And this one, for instance, has one task that does a few things. It calls self.client.get. And client here is brought by HTTP user. And it's an instance of Python requests session object. So it handles cookies and everything. But that's a nice thing as well, because it's a familiar syntax. Like if you've used Python requests, you know how to use this. And again, you can do any kind of programming flows you want. All right, so let's run that. So when you run it in the debugger, you'll get this sort of very basic output. It's just, because I'm only running one user, I'll just echo every request to the prompt. So you can see it doing lots of requests, and the responses are quite slow. But that's intentional. So yeah, that's like, and you can, if you want, you can just put a breakpoint somewhere. Nah, it's too big. I'm not going to do any debugging here. But yeah, you get the picture. If you run into some issue with your tests, you just run it in the debugger as you would any normal code. And now, let's see what it looks like when you actually run a test. So I'm going to start, and I'm going to make it a little bit bigger, and I'm going to take away all that stuff. So basically, I'm just specifying which script I want to run, and I'm saying use the modern UI, because there's a new UI, but it's not yet the default. And it's going to start a web server. And I'm going to say, I want to start 50 users. The number of users here is the number of instances of your user classes that Locust will create. And we're going to point it to localhost, which was already in the file. So great. So this is just a table of all the requests that are being made, aggregated data now instead of just every request for themselves. Yeah, and this is some useful stuff, but usually we want to go straight for the charts. So this shows us the number of requests per second that are being made, and if there are any failures. And the second one shows us the median and 95th percentile response times. You can configure exactly what this is showing. And here at the bottom you see the number of users. So we didn't, I didn't mention it, but I told Locust to do 1 user per second. So ramp up to 50 users, but do it just 1 per second. And now we can see something interesting happening. Because while we were ramping up, in the beginning, the number of requests were ramping up quite nicely, linear ramp up in the number of requests as well. But after a while, we see that response times start increasing, and the number of requests per second is just flattening. This means we have reached some kind of bottleneck in our system. Okay? And there are lots of other views here, mostly for when things break or go wrong. New feature in the modern UI is that you can actually see Locust's own logs here, which is nice, because otherwise people were they forgot to check the command line where any errors might have been output. Okay. Let me just find my browser. There we go. All right, it was supposed to do a headless test as well. Let's do that. So say, instead of the GUI, we want to do everything on the command line. And we say, users 50 and run time 2 minutes. I'm not going to do 2 minutes, but you get the picture. And instead, you get this command line output. This is actually what I use most, because we have a different reporting solution that I'm going to show you later. Cool. All right. So time for a short ad break. As I mentioned, I work for Svenska Spel. We are the state-owned gambling operator. We have offices here in Solna and in Visby. And we use a lot of Python, not just in load testing. And we're currently looking for test automation engineer, but that's actually in Ruby. So do with that what you will. But thanks to Svenska Spel's generous policy of promoting open source, a lot of our in-house developed stuff can be used for free. And one of those things is called Locust plugins. It's a set of extensions and additions for Locust. It's not as well tested as core Locust, so it's a bit more rough around the edges. It provides you with some additional user classes, for instance. You can do WebSockets, Kafka, MQTT. You can even do Playwright for browser-based tests, but the performance isn't that great. But the real killer feature of Locust plugins is called dashboards. And it's a Postgres-based backend for Locust combined with the Grafana dashboards for analysis. So Postgres timescale. And I'm going to show you briefly what it looks like. So this first page, it's sort of anonymized, but you can see this starting page is quite similar to the Locust web UI. And this is also like real time, you can refresh it. And you can get much more detailed graphs. So these graphs are broken down by request, which request was done. And yeah, you can customize the dashboard. It's all just SQL. So if you need to filter or query or do something crazy, you can. And it's also very easy just to zoom in on times. And also I have this nice scatter plot, which plots individual requests. In this case, for instance, you can see that the load is not very good. The load is bunched up in time. So there's a lot of time where there's no requests going out, and then there's just bursts, which was not actually intended. Dashboards also provides like a log of all your runs, so you can find your old runs, and you can also do the stuff that's at the bottom here, which is track performance over time. So if you do this for every release or something, you can see where performance is getting better or worse. We also use something called Locust Swarm. It's a terrible name. I wish I named it something else because of, well, Docker Swarm and Swarm in Locust is actually also a thing, so it's very confusing. But it's used to spawn a whole distributed load test. It uses SSH to distribute the load test itself and then launch the worker processes. And it's, I made it so, but it is super neat because because it does basically this exact same thing as Locust does. So it takes exactly the same parameters. It just does it for you. Just distributes it, launches lots of processes. It has a few extra parameters, but basically it's the same parameters as Locust. So it's very drop-in replacement. And then we have another tool, which is called Hard2Locust, which converts browser recordings or HTTP archives into Locust test scripts. It's very good to get started if you haven't made a Locust test script before, or you're struggling with something, or you can't really make it exactly the same as in the browser because it doesn't work, then maybe you can just record it. All right, so now for the fun part. We're gonna look at, like, the test script I showed you before was really basic, right? You could have done that in any tool. That's not fun. So now we take a deep breath and we look at a more advanced scenario. There we go. Okay, I'm not going to show you the imports. So another test scenario, I'm connecting to MongoDB because that's where we keep our test data, like a list of customers and stuff like that. And I am installing a custom command line option so that you can do Locust -- car budget, because for some reason we have a car budget and we keep changing it all the time, so we didn't want to keep it in the file. We add another event handler so that after each request, if it fails, it just restarts the task. Very useful if you have long functional flows, like if the login fails, there's no point in continuing on, which is otherwise the default. And we're not happy with just regular Python requests performance. So we can use fast HTTP user, which uses LLHTTP and G-event HTTP client, which is compiled. And we want to do something called constant pacing. So we try to target one task iteration every 60 seconds, regardless of the response time of your system. This is very important to keep a constant load. Yeah, we can go into that later if we have time. Constant versus not constant pacing. Yeah, and there's an on-start method in users as well, so that if you want to do something every time a user starts, but not do it as a task, you can. And here we are doing something called catch response, which means that instead of just calling self.client.post, we call it using a with block, and in it we can manipulate the response. We can fail this request based on some condition. And again, notice I'm not doing any manual cookie handling, so if the login here is sending a cookie, it will automatically be handled. And you can do something called weighting of tasks. So for some reason, we want this task to run 90% of the time, and this one only 10% of the time. So we give this a weight of 9 and give this a weight of 1. And you can do, of course, anything regular Python can. So we can do random parts of the request. And you can do control flows, like this one, for instance. We try to get a Ferrari, and if the price is not lower than, or if the price is lower than our car budget, then we're happy and we move on. And if it's not, we just keep trying. And you can also do cool stuff. You can send trace information. If you're using OpenTelemetry or Jaeger or something else, you can do that. We do that. It's super useful. So you can follow the request through all your systems, including Locust. And you can also do, like, as I mentioned, we have a socket IO user. It's actually WebSockets, but then some extra stuff. But so it works for WebSockets regular as well. Where you might have some pushes. So this is from Locust plugins, not part of Locust core. So you can connect to a WebSocket, send some stuff there. Yeah. All right. Yeah, I also mentioned that you can wait tasks, but you can also wait users, which means that you'll have fewer or more instances of a certain user type. Let's see if I can. There we go. Okay, so why isn't everyone using Locust? Python just isn't as fast as compiled languages. So to be honest, if you need like guaranteed millisecond accuracy, if you really need to know that your requests come in after 100 milliseconds and not 99 or 102, this probably isn't the tool for you because, well, Python isn't that fast, and also there are some other like Locust processing. Yeah, just use it for the stuff that it was intended. But you can still do lots and lots of requests. And as I mentioned, the fast HTTP client helps a little bit with this. Because of the global interpreter lock, you need one worker process per CPU core that you intend to use. Hopefully, this could be solved in the future, which is going to be awesome, but we're not there yet, and it might take a while. And as I mentioned, you can use Locust Swarm. That makes it trivial. You just say how many processes do you want, and it does that for you. Yeah, and just a note, it's for us in this room, writing a performance test in Python is a big benefit, but some people might find it harder, and it's easier for some people just to configure stuff rather than write code. But with any other, Python project, you should use linter and static type checker to help with this. Locust provides type hints for almost all of its APIs, so it helps. And also, if you do get stuck, you can go on our Slack or ask on Stack Overflow. So, a bit of a summary. Locust is just Python, and it's easy to write simple tests, but it really shines in the more advanced scenarios. It can be scaled to massive amounts of users, and like previous speakers have said, it's important to have fun. And I think this is fun. It's much more fun than learning the quirks of some tool, which is pretending to be code, but really isn't. Yeah, with that, open up for questions.
Thank you very much, Lars. We have time for quite a few more questions than last time.
Hi, this is this is really impressive. If I wanted to implement a smaller binary protocol for communication and try this and use this with Locust, would that be reasonable for me as a individual with not endless amounts of time to do?
I actually don't know. I think I haven't done that part myself. It's it should be possible. There's also the ugliest of workarounds, which is just to run a single process per user, which you can do. But yeah.
And also, you can parallelize everything, but do you have any ballpark figures of how many requests, just simple GET requests, you can do with a single process?
Yeah, so it's really hard to say because your test scenarios will differ, but I would say that with the regular HTTP user, you can do at least over 1,000 requests per second per core. With a fast HTTP user, it's somewhere around maybe 4,000 or 5,000. So that should be plenty, right?
Okay, I think I'm there. Is this on? There it is. You said you have MQTT support. That's very interesting. But that is a very different protocol from HTTP, since there you will get, of course you can do like a GET request and get something back, but you also have a stream of data coming, published messages. Can you also do load testing where you get some numbers for how well it handles incoming messages and stuff like that?
Yeah, absolutely. I'm just going to bring up the implementation of the MQTT user. So basically, because it's a good example as well. Oh, it's very small. So what you basically do when you want to report something to Locust, you fire an event, a request event, and you can do. Where is it? I didn't write this one myself, so. Yeah, so you can. This one, for instance, is a publish event. And we're firing a publish event, but you can also this one, for instance, is subscribe requests. Let's not get into it too much, but you can do anything. I would say it's easier for a request response based protocol because you have this concept of response times, which might not make sense in a publish subscribe world, but you can do it. So if you have like I've done sometimes I've done the workaround of like injecting some timestamp into my payload and then reading it on the other end, and then taking the difference between that and calling that my response time. So there are ways to do it.
Thank you very much. Thank you very much, and thanks for a great speech.
And now, a one-sentence answer to the last question from here.
Hello. Thanks for the talk. I wanted to ask how you handle reproducibility in test results between test runs. Especially in CI, where multiple supporting applications like, I don't know, the database or the document store might end up spawned on different nodes geographically, separated by network, but might not. Don't you get like outliers in the results, or how do you handle it in Svenska Spel?
So for CI, Locust plugins provide some extra features where you can set targets and you can fail the whole run based on like request rate or response times or failure rates. But what you need to do if you need to know stuff about your infrastructure, you can either make Locust ask for it, like at the start of the test, at the end of the test, or even during the test, you could just poll something like CloudWatch or whatever you want to ask, or you do it parallel. Like if you use the Locust plugins dashboards, that's just another Grafana view, and you can maybe link between them or do whatever. So it's not built into Locust. There's no monitoring built into Locust.
Okay, thank you.
Thank you very much, Lars.
Thank you.